Hi, my name is JGates-Lupton, and today I'm going to be talking about a problem regarding the resistance of a heating element. So for this problem, we have two wires, both of which have two different resistances in a heating element. Now, I've chosen to represent these as resistors because we're working with their resistances, um, and our goal is to find out what their total resistance is when the heating element reaches a temperature of 50 degrees Celsius. What the problem gives us is the resistance of both wires at 20 degrees, 600 ohms and 300 ohms. It also gives us these two coefficients. Alpha 1 equals 0.0011 over Celsiuses, and alpha 2 equals 0.0041 over Celsiuses. So, what is alpha? Alpha is the temperature coefficient of resistance. It's the change in resistance of an object as the object increases in temperature. Uh, it's essentially just the slope of this line where the resistance of the object is increasing and the temperature is the cause of that. So if we take alpha to be equal to the slope of the line, y over x, then we'll get the coefficient of resistance. So why does an object increase in resistance in response to an increase in temperature? So at the atomic level, we have free electrons moving around as a result of the voltage drop. And when they move through the object, they can crash into the ions, the positive ions that have lost their free electrons that are vibrating around, and that slows them down. Now, when that happens, the degree to which it slows these down is the resistance itself. Like that's what causes resistance. And as the temperature increases, the ions vibrate more intensely. So it's much more likely for the electrons to hit them, and therefore the object has greater resistance. So in order to solve this problem, we're going to have to look in the FE manual under Instrumentation, Measurement, and Control and look at temperature sensors because they have an equation here that models the resistance of a resistor as a function of a reference resistance and a reference temperature, as well as alpha. Thankfully, we have all of those. We have the temperature that we need to look at the resistors at. So again, at 20 degrees, this was 600 and 300 ohms. Alpha does not change with temperature. So for R1, if we look at the formula that we were just given, we get 600 times 1 plus 0.01 times the difference between 50 and 20, the temperature. And for R2, we get 300 ohms times 1 plus the alpha 2 times the difference between 50 and 20 degrees Celsius. And that is going to be 618 ohms and 336 ohms, respectively. Add them together, and we have the solution. Thank you.